Okay, so let's try to find these functions based on the graphs. So this first graph, there is a horizontal asymptote. So right away, this is exponential. And we know the base is 2. So this has got to be 2 raised to the x, this function. There is no horizontal shift. So that means I'm not, shifting to the left 3. I'm sorry, yeah, or to the right 7. There's no horizontal shift. But there could be other things. There could be a vertical shift and there could be a vertical stretch. Now I know there's a vertical shift down 1 because the parent function would have a horizontal asymptote at y equals 0, but this one is occurring at y equals -1. So I know that my function ends in -1. It's something times 2 to the x minus 1. Well, how do I find the vertical stretch? I need to pick ordered pairs. I've got 2 options here. This looks like, I don't know what that looks like. This looks like 0, 2. So let's use that. If I type in 0 into x, by the way, this is y equals. So 0 into x results in 2 for the y value. So I'm solving for a. 2 to the 0 is just 1. If I add 1, I get 3. So I discover a is 3. And this is my function. It is 3 times 2 to the x minus 1. That is that function. On number 2, again, another horizontal asymptote. So this has got to be an exponential function. And my base is 1/5. So it's y equals 1/5 to the x. I'm told that it was shifted to the left 2, and that will shift it to the left 2. I don't know of any vertical stretch, and I'm not sure of any vertical shift. Well, I do know the vertical shift. I'm sorry. The horizontal asymptote is at 0. That's what the parent function will be. So it did not shift up or down. So there was no vertical shift. But there may have been a vertical stretch. So how do I find this? I plug in ordered pairs to find a. I'll use this one since it's got 2 integers. So I have -1 is the y value. That happens when x is -2. And I get -1 equals, 1/5, excuse me. 1/5 raised to the 0. This is -1 equals a times 1, which means -1 equals a. So this is, I know my function. The a value is -1. The base is 1/5. It was shifted to the left 2. That's what they told me. I can see that there's a horizontal asymptote at y equals 0, so it did not shift up or down. Number 3, I see a vertical asymptote. So this is a log. And I'm told that it's base 3. So this is log base 3. And this vertical asymptote is at x equals 0. So that means there was no shift left or right. There is no vertical stretch. So the a value would just be 1. So this is y equals 1 times the log base 3 of x. But maybe there was a vertical shift up or down. I don't know. But I have some ordered pairs to help me. Let's use 3, 3. The y value is 3 when the x value is 3. Well, what is log base 3 of 3? It is 1, because 1 is the exponent that would go in 3, that would result in 3. So 2 is k. What does that tell me? That tells me that this logarithm shifted up 2 units. So my answer is log base 3 of x plus 2. Number 4, there is another vertical asymptote, this time at x equals 3. So that tells me 2 things. I know that it's a log and that it's shifted to the right 3. Furthermore, they tell me that the base is 2, so it's log base 2. They told me that it's shifted up 2, so it must be plus 2. and I do not know any vertical stretch. So I don't know my A value. And I've got, looks like I've got two order pairs. I mean, I've got many order pairs to choose from. I want to pick the one that is that's easiest to me. This is 7, 0. Let's do that. So 0 for Y. And 7 for X. So what do I get? 0 equals the vertical stretch times log of 4. So now I have to know, what is log base 2 of 4? It is 2. So I solve for A. I discover that A is -1. So I know that there was a reflection, not a stretch, so to speak, but a reflection. All the Y values got multiplied by -1. Number 5, another vertical asymptote. So another log. And this logarithm did not shift left or right because the vertical asymptote is still x equals 0. I'm told the base is 2, so it's log base 2. There was no vertical stretch, so I don't have to worry about that. But maybe there was a vertical shift up or down. I don't know. So let's find out. I can pick any ordered pair. Let's just choose, it doesn't matter. Let's just choose this one. This is the ordered pair 2, 4. So when Y equals 4, when X equals 2. Now you get to know something about logs. What is the exponent on 2 that results in 2? That is 1. So K equals 3. And now I know my function. It is log base 2 of X plus 3. Last one, number 6. I see a horizontal asymptote at 3. That tells me it is exponential. The base is a half. And since normally exponential functions have a horizontal asymptote at y equals 0, but this one is at y equals 3. That would only happen with a vertical shift up 3. They told me that there is no horizontal shift, so I don't have to worry about to the left 1 or to the left 4 or to the right. I'm not really, I don't have to worry about any horizontal shifts. There may have been a vertical shift. So I again have to pick an ordered pair, plug it in, and let's pick this 0, -3. When y is -3, the x, I'm sorry, that y is -3 when x equals 0. And anything to the 0 is just 1. I subtract 3. So I discover that A is -6. So this is a stretch of 6 flipped over and then raised up 3 units. The backside were logistic, and 6 over 1 plus 0.5 is the same thing as 6 over a half raised to the x. Now, what happens to the y value when x gets really, really big? Well, if x gets really, really big, then 1/2 gets really, really close to 0. 1/2 times 1/2 times 1/2 times 1/2 is a positive number, but it's really close to 0. So when x gets really large, again, 1/2, that 1/2 goes to 0. So I'm left with 6 divided by 1 plus 0, which is just 6. So that is one of my horizontal asymptotes. What happens to the y value when x gets really, really small? Well, if x gets small, like -100, let's say, then that's the same thing as 2 to the positive 100. And that's very, very big. So when x gets small, this denominator gets very, very large. And 6 divided by a very, very large number is essentially 0. So the second horizontal asymptote is y equals 0. So I draw them in. The domain for these logistic functions are always all real. The range is determined by those two asymptotes. It's never going to be 0. It's never going to be 6, which means there is no x-intercept. But there probably is a y-intercept. There must be, because the domain is all real. So that means 0 is in the domain. If you plug in 0 into that function, you get 6 over 1 plus 1, which is 3. So the ordered pair is 0, 3 for the y-intercept. And now I'm ready to graph. I'm looking back at my end behavior was up top. That's my end behavior. So my end behavior is describing what is happening when x gets small and when x gets big. Well, when x gets big, the y value gets close to 6. When y gets small, the x value gets close to 0. And so there's the function. It is increasing on its entire domain, and it's never decreasing. For this one, the domain is all real. I can find the y-intercept right now. If I plug in 0 for x, I get 2. So 0, 2. And let's now, the end behavior really helps us here, finding the end behavior. So let's find this end behavior. What is happening to y when x gets very large? Well, when x gets large, 3 to the x gets really large. And ultimately what that leads to is 4 divided by a very, very big number. So when x gets large, you have 4 divided by a big number, which is approaching 0. So that's one of my asymptotes. When x gets small, then 3 to like the negative 100 will be approaching the number 0. And when x gets small, that function approaches 4 divided by 1 plus 0, which is just 4. So here are my two horizontal asymptotes. Y equals 4 and y equals, I could do that better. Y equals 4 and y equals 0. And this is enough to graph because as x gets big, I'm getting closer to 0. So when I graph this thing to the right, my y value is getting closer and closer to 0. And when I graph it to the left, it gets closer and closer to 4. So this is never increasing. It is always decreasing over its entire domain. And there is no x-intercept, and the range is between 0 and 4. Last problem. I'll start with the end behavior. What is happening to the y value when x gets really, really big? Well, this one, let's see here. This is really 1 plus a half to the negative x. Well, that's the same thing as 1 plus 2 to the positive x. And that's much easier for me to understand, changing that negative exponent to a positive. So when x gets really, really big, this gets really, really big. And what you have is 8 divided by a very large number, which is essentially 0. What y value is being approached when x gets really small? Well, if x gets really small, this approaches 0. And when that approaches 0, you have 8 divided by 1 plus 0, which is essentially 8. So those are your two horizontal asymptotes, which tells you your range. Good. The domain, of course, is all real. The y-intercepts. If you plug in 0 for x, you're going to get 4 for the y value. There is no x-intercept. And when x gets really, really big, it's getting closer to 0. When x gets small, it's getting closer to 8. So there you have it. It is never increasing. It is always, or it's decreasing over its entire domain.